Hello again. In this video, I will be trying to solve two examples, simple one, about capacitors and capacitance and how you calculate that. Now, the first question saying here, a parallel plate's capacitor has 8.2 centimeter radius and 1.3 millimeter separation. Calculate the capacitance. Now, from the description, I understand that I have two parallel plates. They are circle shape because the radius. So I know for start that I need to calculate the area of a circle, and the other thing, the distance between the two plates, if I assume that's the battery is connecting them. The distance is 1.3 millimeter. Now what I'll do, I will say first of all I need to apply the formula. We know the capacitance equal the permittivity multiplied by the area over the distance between the two plates. Now the permittivity, it's a constant, it's 8.85 10 to the power minus 12. And the area, I should calculate the area of the circle. It is a pi r square divided all on the distance, and we need to remember we don't use millimeter. Sorry, I wrote here meter, it's a millimeter, the information. So it is 1.3 10 to the power minus 3. So once again, it's 8.85 10 to the power minus 12. That is a pi multiplied by the radius squared. So it is 8.2 10 to the power minus 2 first, and it's a square. So I convert it to meter first, then square the whole thing, divided on 1.3 10 to the power minus 3. Now, simply if we just do the calculation of this one, okay, that will give us 1.42 10 to the power minus 10 farad. That will be the capacitance of this capacitor. Okay, so it's just to bring the attention that to your attention that the plates could be circle, could be square, could be rectangle. Any shape we want in our question can be designed for the plates of a capacitor. Now, the second example, I have a 100 coulomb of charge is stored when 20 volt is applied across a capacitor, right? Now, first of all, determine the required voltage to store 300 coulomb of a charge. And the second one, how much charge can be stored if 150 volt is applied. Okay, as a start, I need to know what is the capacitance of this capacitor. So first of all, I would say, all right, C equal Q over V. That will make it 100 coulomb divided on a 20 volt. That will give me a 5 farad capacitance. Okay, so now I know how much is the capacitance of this capacitor. For the second part, the first question, he's asking me to find the voltage to store 300 coulomb. So I can rearrange this formula in another form to find the voltage, and it will be Q over the capacitance. All right, now Q, it is 300 coulomb he's asking for, and the capacitance we have, it is 5. That will give me 60 volt. That's the voltage required to be able to store 300 coulomb in this capacitor. For the second part of the question is how much charge can be stored if I have a 150 volt applied across the two plates. Okay, the same formula here. We're not going anywhere from this formula. We're just gonna rearrange it. We're asking for the amount of charge. It's the capacitance multiplied by the voltage. Okay, that's the capacitance. It's 5, and the voltage is 150 volt. That's give us 750 coulomb of charge can be stored in this capacitors if we apply 150 volt potential difference across the two plates. All right, these are the two questions for this video, and hopefully I see you with another video later on. Thank you.